Welcome to Geometry Section 1.1, Lines and Segments. Today we're going to use proper notation to identify points, segments, rays, and lines, and then understand congruency as it relates to segments. In the next video you will see how to identify lines of reflection and then reflect an image or a point over a line of reflection using patty paper or just by using that line of reflection and reflecting the image. We're going to begin with some algebra review in Activity 1, so go ahead and pause the video to complete this algebra review. The next time you unpause the video, you will see all of the answers with the worked out solutions that we will go over. For number 1, you'll see that we added 5 to both sides, divided by 2, and got x equals 9. For number 2, when x is on either side of the equal to sign, we must bring all the x over to the one side and then the constant number over to the other side. So I went ahead and moved the 3x to the other side using subtraction. So we have 2x minus 8 equals 12. I added 8 to both sides and then divided by 2 to get x equals 10. For numbers 3 and 4, they both involve distribution. So for number 3, I went ahead and distributed the 2 to both terms, making sure that we distribute that 2 also to the 1. Then I subtracted the 2, divided by 6, and got x equals 3. For number 4, I went ahead and distributed the 3 to both terms. Then I went ahead and distributed the 6 to both terms. I made sure to get the x's on one side and the constant number on the other side. And when I divided both sides by 24, I was able to reduce the fraction to get negative 9/8. Go ahead and pause the video if you need time to catch up when writing down all of the worked out solutions. In this next activity, we're going to learn how to notate points, segments, rays, and lines. So our definition of a point, it's just denoted with a capital letter. That's not exactly a definition, but we have points that are on the ends of segments. We have them on the ends of rays and through a ray. We also have them along a line. Segments. Segments have a start and an end point. So they start and end at definite points. We name a segment with the endpoints. So for this segment, we can call it GO, or we can call it OG. If you notice, it has a little line above the 2 letters, depicting that we have a segment. For rays, they start at a point and continue in one direction forever. Rays are named with the endpoint and then any other point along the ray that goes through the arrow. So we can call this ray AC, and if you notice I drew the arrow symbol above the C. We cannot, however, call it CA with an arrow above the A. So because that arrow is going through C, we have to make sure that the symbol above the 2 letters that we write go through that letter too, so go through that point. So not CA, but we can call it AC. And then finally we have lines. Lines continue in both directions forever. There are 3 ways to name this line. We can call it LW with an arrow on either end. We can call it WL. So in this case, we can flip the direction because there are arrows going through both W and the L, or we can call it by its cursive letter. Go ahead and practice numbers 1, 2, and 3. You're going to name this segment in all possible ways. There are 2. You're going to figure out which way the ray can be named. And then finally, you're going to name the line in all possible ways. And there are 7 ways to name this line. Go ahead and pause the video and name each segment, ray, or line in all possible ways. For number 1, We can name it CT or TC. Notice I never use that A, and we can only use 2 letters when writing the name of a segment, so never 3. So we did not use that A. We depicted from C to T, that is the full segment length, so CT. Number 2, the ray can only be named as FE with the arrow going through the E because F is an endpoint. And then finally, number 3, name the line in all possible ways. We have arrows going through all points. So we have DG, GD, DO, OD, GO, OG, and then we have our lowercase cursive I. In this next part, we're going to talk about what it means to be congruent. So we have objects are considered congruent if they are the same size. In geometry, we use this symbol to denote that objects are congruent. So objects that are the same size, they're said to be equal, and this geometric symbol that we use is called the congruent symbol, and it just means that we have 2 different parts of a segment that are equal or congruent. They're the same size. It means that the objects are known to have the same measurement without actually having to measure them. So we have all of our segment lengths. We can attach a unit to them, a unit meaning a measure. So we can say that there are 2 inches in the segment. There are 3 centimeters within the segment. It is only 5 feet long, the segment. So we use the congruent symbol to show that objects are the same size. They're equal. Rays and lines can never be considered congruent because they have arrows going through them. There are no definite lengths to a line or to rays, and since arrows go on forever and ever, we can never say that they are congruent. Number 5, it says it is known that AB is congruent to CD. So we have that congruent symbol right here. Congruent means equal. It says additionally, we have AB is 3x minus 5, and CD is 5x minus 13. To find the measure of CD, our end goal right here, find the measure of CD, what we're going to do is we're going to figure out what x is, and then I can input the x into CD to figure out the exact measure. Now in order to do so, I'm going to take AB, which is right here, 3x plus 5, 3x minus 5, and because congruent means equal, I'm going to set it equal to CD. And CD is right here. So we're going to set it equal to 5x minus 13. And then we're going to go ahead and solve for x. So go ahead and solve for x. We will get that x equals 4. However, that is not our final answer. We need to find the measure of CD. So I'm going to take the 4, and we're going to input it into 5x minus 13. Input it into the x. So you have CD equals 5 times 4, which is 20, minus 13. So my final answer is 7. In number 6, it says in the diagram below, PR is 6x minus 1. So I'm going to go ahead and write that PR, and we have 6x minus 1. Then it says that RO is 2x plus 5. So I'm going to write down that RO, 2x plus 5. And then it says that PO is 52. So PO is from start to finish. The whole length is 52. Because these 2 smaller segments combined make up the larger segment, I'm going to use addition to show that these 2 segments that I can combine make up the bigger segment. So we have 6x minus 1 plus 2x plus 5 equals 52. We're going to go ahead and solve for x and then plug it into x to find the length of PR. Go ahead and pause the video and solve for x. Once you get that x equals 6, you're going to go ahead and input the 6 into 6x minus 1. So we have PR equals 6 times 6 minus 1. So 36 minus 1 is 35. So the length of PR is 35. So in number 6, nothing was congruent. However, these 2 smaller parts made up the larger segment. So we're able to add them and combine them and set them equal to the larger segment. And number 7 pictured below is segment DT. O is the midpoint of the segment. Point O divides DT so that DO is congruent to OT. So there we have the congruent symbol. I'm going to go ahead and circle that. It says if DO equals 3x minus 1, so I'm going to go ahead and write in that DO is 3x minus 1. And then it says that DT is 8x minus 22, which is the whole segment. We need to find the length of OT. Well, going back to that word congruent, that symbol that we said, DO being congruent to OT, we can denote in our picture with little tick marks that DO is in fact congruent to OT. I'm going to go ahead and highlight them in yellow. So because they're the same measure, we can go ahead and write in that OT is also the length 3x minus 1. So now we have two different parts, 3x minus 1 plus 3x minus 1. And both of these two smaller segments make up the larger segment. So I'm going to set them equal to, add them together and set them equal to 8x minus 22. Go ahead and pause the video and solve for x. We find out that x equals 10. To find the length of OT, we're going to go ahead and take the 10 and plug it in for x. So we have OT equals 3 times 10 minus 1, which equals 29. And then finally, number 8, it says the measures of 3 segments are given in terms of x. It says AB is 6x minus 6, DE is 3x plus 18, and RS is 5x plus 6. Now, if AB is congruent to DE, is AB congruent to RS? So what we're going to do is we're going to use this information right here and set AB congruent to DE, figure out what x is, and plug the x back in to figure out if they are all the exact same measure. So AB, so we have 6x minus 6, and the question is, will this all end up being the exact same? So I'm going to set it equal to 3x plus 18. Pause the video and solve for x. You should get that x equals 8. So now let's figure out what all of the segment measures are. So we have AB, so we have 6 times 8 minus 6. 48 minus 6 is 42, so that's one of our lengths. And let's see if it is congruent to RS. So RS, we have 5 times 8 plus 6. So we have 40 plus 6, which is 46. And it turns out, no, they are not congruent because one length is 42 and the other is 46. So therefore, they are not congruent. And that concludes our lesson for today on segments, rays, lines, and congruency.